And as usual, I use the term loosely. Hey, welcome back to the shop. Today we're going to make a sissy bar. And we're going to do a little math on it first to just calculate a couple things before I dive into it. Usually I would just grab a piece of 1/2-inch bar stock and a torch and start heating stuff up and bending it. We're going to try to be a little more refined today and do a little planning ahead. Like I say, normally the way I make a sissy bar would be I'd machine a steel boss, and it'd be counterboard, so I could put a socket head screw in it and it would be flush. And then to the boss I would weld, a 1/2-inch steel bar to the next boss, which would also be machined and counterboard to accept the 5/16 screw. And then I would bend the next hunk of bar up and over and around, and I'd weld it to another machined steel boss, also counterboard for a socket head screw. And then of course another 1/2-inch steel bar welded to another machined boss. Kind of labor intensive, a little bit difficult to execute. So today, for simplicity's sake, I want to stand by. We'll call that guy back later on. Anyway, today, to kind of simplify the process, I just want to make the whole sissy bar out of one piece of steel. And your choices, most guys use 1/2-inch round stock, 1/2-inch square stock. I don't want to use 1/2-inch square stock because I plan on securing with 5/16 screws. Well, if you start with a piece of 1/2-inch square stock, that's 8/16. You subtract 5/16 for the screw hole in the middle. That leaves you with 3/16 altogether, and that's going to leave you with just 30 seconds of material on either side of the screw hole. That's not a lot of material. That's less than 1/8 of an inch of material. So I just don't think that's going to be strong enough for our purposes here today. And so I'm going to use 5/8 inch stock. So 5/8 inch stock is, 5/8. So that is 10/16. And from that we're going to subtract the 5/16 for the hole for the screws. That's going to equal 5/16 left over, which is going to be 5/32 of material on either side of the screw hole. So an extra 1/16 of an inch of material altogether. So we're going to use 5/8 because I think it's going to lead to a stronger sissy bar in the end. Now, the way most guys do this would be, here's a piece of a 3/8 inch rebar. We just heat it up and bend it. Well, when you do that, what's going to happen when you start using a heavier stock like 5/8 is this part is going to stretch quite a bit, and it's probably going to crack there even though it's heated up red hot. The other thing that's going to happen is this part over here at the inside part of the bend is going to get all squished together, and it's going to pooch out and get fat. So you're going to end up with a big lump over there, which is no problem. Of course, it can be ground down. But in the meantime, you got the stretched out part over here, which is going to be real thin, and it's probably going to crack. So, I don't want that to happen. So what I want to do with it is I got my 5/8 inch bar. What I want to do with it is drill a hole over here. I don't know, maybe a 3/16 hole or whatever, maybe just an 1/8 of an inch hole. I want to drill a hole over here. Maybe just an 1/8 of an inch away from the edge, and then I want to remove a certain amount of material over here so that when I bend this bar around, it'll close up that gap and leave me with just a seam, down the middle over here that I quilt. So when I'm done with this, it's going to look something like this. Be a hole over here. There's going to be an angle cut over here and an angle cut over here. These two angle cuts are going to come together in the middle. I'm going to weld it, and then the bar will be structurally secure at that point. So anyway, the question then gets to be how much material do I need to remove over here? Well, one way to do it might be just to take a guess, go out there and start chopping and sawing and seeing what happens. But you know what? Mathematically, we could figure it out. When you look at the sissy bar, you got two sides, 18, 18, and across the bottom over here is 6. So you have a triangle. And go back to high school mathematics. I was not good at high school mathematics. I was pretty good at geometry, not so good at mathematics. This particular thing we're going to look at kind of crosses both lines over there. You know, back in mathematics class, I had a teacher's name was Mr. Strimple. I ain't making that up. You can't make up a name like Mr. Strimple, but that was the guy's name. Had he told me that these clever little mathematical tricks he was going to tell me about could be used at some point in my life to design a sissy bar, I would have said, first of all, you're fucking crazy. And then I would have said, well, you know, maybe I could use that shit later on, so I'll pay attention. But I didn't, so I'm not good at it. But anyway, you can figure it out. And we're going to use the laws of cosines to figure out how much metal to chop out of that 5/8 inch bar before I bend it. So we have a triangle, and we're going to label the angles of the triangle A, B, and C. And by convention in mathematics and geometry, the side opposite of angle A is little a. So we're going to call this little a. It's 18 inches long. The side opposite of uppercase B is lowercase b, also 18 inches. And the side opposite uppercase C is lowercase c, 6 inches. So we're going to use a cosine formula to figure this out. So the cosine of angle A is equal to b squared plus c squared minus a squared divided by 2 times sides B and C. So to start simplifying this problem, solve it, we get rid of the a squared and b squared because those two numbers are the same, they're equal. So we're going to be left with c squared divided by 2 times b times c. So in our formula over here, cos A is equal to side C is 6, so that's going to be 36 divided by 2 times B, 18, and C, 6. So we'll do that little calculation over there. Let me get my calculator because I can't add and multiply what the fuck could come out wrong anyway. So let's see. 2 times 18 times 6 equals 216. So 36 divided by 216 cos A. So 36 divided by 216. Whoops. Is 0.1666, a bunch of sixes. Okay, so cos A is equal to that. So we want to get rid of the cos part of that so we can figure out what angle A is. So A is equal to cos negative 1 times 0.166666. Okay. So we'll turn the calculator sideways because it goes in scientific mode over there. Yeah, okay. And you press the second button over here back and forth if you got one of these kind of calculators, and you hit cos minus 1, boom, 80. So angle A is equal to 80.4. 80.4 degrees. So there you have it. Angle A is 80.4. We'll just call it 80 because that's going to be close enough for this thing. Since it's an isosceles triangle, both of these sides are the same, we know the angle B is 80. We know in a triangle that the sum of all 3 angles adds up to 180. So 80 and 80 is 160. It has to add up to 180. Therefore, angle C is equal to 20 degrees. So 20 degrees is what this angle is in here. And that's the number I wanted to know. Now, coincidentally, well, not coincidentally, on purpose, because I didn't trust the math absolutely that I'd be able to figure it out, I made a drawing to scale, and the scale is 1 inch of the real thing is equal to 1/2 inch on the drawing. So if you scale it out, you end up figuring out when you just measure it with a protractor, if you draw it to scale, that boom, this angle is 20 degrees. Half of it I divided down the center line here. So 10 and 10 is 20. So the calculation came out correctly. It's 20, that's what we need to get to, 20. So when I get a hold of my chunk of 5/8 inch steel, we're going to figure out how long it is, and we're going to take that piece of steel. Let's see here. We're going to drill a hole in here like I was planning on, and we're going to cut, I think this is going to be 10 degrees from here and 10 degrees from here. So we're going to remove this piece of metal, and when we fold these two together, boom, these two edges ought to line up and create a seam that can be easily welded, and it should create a nice even bend without a lot of distortion, with little or no danger of cracking this thin part up here where it stretches, and that should work out perfectly. So let's go cut the steel bar, make some measurements, drill a hole, and go bend it. All right, lopped off a piece of material a couple inches longer than I think it's going to need to be. Mark the center of it. I'm going to mark our 10-degree angle that we want to take off of this thing. Let's see. We'll do it about here to here. Reverse it and go the other way. All right, we'll put a hole over here, and I'll take after this thing with the cutoff wheel and angle grinder and remove this chunk of metal in here, and then hopefully we'll fold this over together, and when it's 6 inches apart, 18 inches from the top, that should close this gap up, and it should work. So let's go do it. Perfect. All right, let's go for a little fire. Just FYI, I marked the layout line where the sissy bar should end up after I finish my bend. And that is pretty sweet. Six inches on the money. Our gap closed up nicely. We'll run a nice fat bead in down through there. Good to go. All right, as you can see, the calculation was almost exactly dead nuts on. My gap closed up nicely. I got a nice bend over here. Put a tack on the other side. All right, back out by the dirty shop to do some bending. Got the sissy bar clamped down. This piece of channel is 6 inches wide, the same as the fender. We're going to heat it up over here. We're going to heat it up over here. We're going to bend these legs straight at this point so that they're parallel to the sides of the fender, and I can run my bolts in this way into the fender. Anyway, let's get going on that. All right, we're going to cool that off and do a test fit in a little bit. Okay, we're going to bend the bottom part of the sissy bar out and apart to accommodate the side plates on the axles. At this point here has to be just outside this line. This point here has to be just outside this line. I was having a hard time getting heat into it before. I cranked up my acetylene to 10. I think I was using 4 or 5 last time I heated it. I cranked the acetylene up to 10, oxygen up to 50. I want to get a lot more heat in there a lot faster. This thing is clamped down as secure as I could clamp it down. So I don't want it going anywhere while I got all this thing red hot. So let's fire it up, see if I get lucky again. Okay, last step is going to be to bend it here and here parallel to the axle plates. From here to here has to be 9 9/16 inches. Let's see where we're at. Exactly on the money. Exactly on the money. Once this cools off a little bit, I can reposition my clamps and we'll do the last bend. Maybe I'll get it knocked out tonight. Alright, here's the last setup, the last 2 bends. This piece of scrap is the same width as the distance between the axle side plates. Everything is clamped down. Let's go for it. But got it. Might need a little tweak. We'll do that later. You know, for tonight, I think I'm out of here.